In this video we're going to be looking at scatter graphs, but before we do we want to look at different types of data. So there's two main types of data, and that's discrete and continuous. Discrete is data that can be counted, so shoe size, number of people, number of peas in a pod, things like that, they're all discrete. But continuous data can be assigned over an infinite number of values between whole numbers. So length, width, temperature, time, and things like that, those are all continuous data. The way you might want to think about it is that continuous data is such that if you were to increase the scale, you get a more accurate result. So height-wise, you might be approximately 2 meters to the nearest meter, but in centimeters, you might be 183 centimeters to the nearest centimeter. But you could increase it to millimeters, and you might be 1,829 millimeters. And if you keep going and zooming in and becoming more and more accurate, you're getting a more and more exact answer. So that's what we mean by continuous data. Whereas discrete data, there's only going to be one person or 3 flowers or whatever it happens to be. It's more an exact value. Scatter graphs then are used to show that there's a relationship between two sets of data, and there can be different types of correlation. So what we can see is between shoe size and height, the values are generally going up. So you might read that as the bigger the shoe size, the taller the height. And hopefully that stands to reason. Babies and young children have really small feet, whereas adults have bigger ones. So adults are obviously taller than children, so as shoe size increases, so does height. A negative correlation would be one that decreases. For instance, the sale of soup and the temperature. So if it's really cold, you might have a lot of soup sales, whereas if it's a lot warmer in the summer, you tend not to choose soup. You'd have something maybe like a salad or something a bit more refreshing, whereas soup would warm you up. So that's a negative correlation, and we can see that the lines generally slope down the way. But quite often as well, then there's no correlation at all. So the points on the graph are just randomly assigned with no real pattern. And things like that could be the annual income and your shoe size. So they've no correlation at all, no real link, and there's no pattern at all. So that's no correlation. So a positive or negative correlation is characterized by a straight line with a positive or negative gradient. And note that correlation does not prove that there is definitely a relationship between the quantities. So example, describe the correlation and strength of the correlation of the scatter diagrams below. So this first one, the line is sloping up, so that means it's positive correlation. And then we can also have the strength of the correlation. Now all the points are pretty close to the line of best fit. So that means that it's strong correlation. In the second one, we can see it's generally sloping down the way. The line of best fit goes down, so that means it's negative correlation. And the points aren't as close as the first one, but they're still quite close to the line, so we would say that's of moderate strength. Whereas the last one, again, we can see it's going down the way. It's negative correlation. It's not quite no correlation, but it's pretty close. But the points are all quite far away from the line of best fit. So we describe that as weak negative correlation. So in those examples that we've just looked at, there was a line of best fit that was drawn. And we can do that to help show correlation. The stronger correlation, the easier it is to draw the line of best fit. The line can be drawn by eye and should have roughly the same number of points either side. So if we've got this data, we can try and plot this and see if we can draw a line of best fit. So we've got the point 565 has already been plotted for us. And we've got 12 and 97, 7 and 68, 10 and 92, 10 and 78, 9 and 78, 8 and 76, 11 and 88, 6 and 74, and 8 and 80. So that's all our points plotted. Now we want to try and draw a line that passes through those points with the same number above and below it. So this red line then, we've got 1, 2, 3, 4, 5 points above the line, and 1, 2, 3, 4, 5 below the line. Now the line of best fit that you would draw and somebody else would draw could be all slightly different, but they should be in and around they should be close enough to each other. So answers may vary, but chances are they should be pretty close. So then we can use the line of best fit to guess the mass of a man with shoe size 10.5. So if we go to our 10.5 and draw a line up to the line of best fit, and then from there draw a line across to the axes, we can see that it's approximately 88 kilograms. So a man with shoe size 10.5 would have approximately 88 kilograms, would weigh approximately 88 kilograms. Then we could try for 69 kilograms. So same idea, we move across from 69 and then from where the line hits the line of best fit, we draw a line down again. And we can say that the shoe size would be approximately somewhere between 6 and 6.5, probably closer to 6.5. So we'll say 6.5 shoe size. We don't really get 6 1/4 or 6 1/3, so it would be 6 or 6.5, and it's closer to 6.5, so we'll go for that.